So you must have heard about um, Snowflake or star schema.
I haven't.
Okay, so let me just tell you. Okay, so in databases, when we design the database, right, whether it is SQL Server, Oracle, or Access, or any database in the world, so there could be several relationships what we create between tables, right? And basis that we store the data into tables, like primary key relation, foreign key relation, all those referential integrities. That is what we create. So in case your data, in case your database has one fact table and number of dimension tables. So for example, when I say one fact table basically one table where you have all the, and dimension table we have all the dimensions, different dimensions. So for example, let's say if I take example of maybe let's say a department, right? So fact table can have the salaries of all the employees. Fact table can have all the um, the tax details of different employees. So
So
those are
we
the
can
measures,
say
the numerical values.
anything that can be quantified, numbers, continuous or discrete, will be part
Right.
of fact table.
Correct. Right, anything which is in numerical in nature, and it like it is the collection of different employees or entities within a department or within a segment or within, it can be product costs as well. So on the product fact table we can have like that. So table generally are more. So for example, let's say if I take in case of departments, so it can be, one can be hierarchy, right? It will have all the roles, people role, like who reports to whom, that kind of relation. Another dimension table can be address, wherein I have address of all the employees. Then another dimension table can be related to their work, like which client they are supporting, right? So these type of details I can have in dimension tables. Now overall, if you see uh, the structures like this, wherein what will happen ultimately, each table will have employee ID, not employee ID, but I mean employee ID in terms of foreign key or primary key. We can join all these dimension tables with the fact table, so that whenever, let's say, uh, I need to get all the clients and their salaries, the people who are reporting to these clients or handling these clients. So in that case, I will join this table and this table,
So Satendra,
right?
can you please explain me the meaning of foreign key and the other key that you said? I am not aware of these terms.
Okay, so let's say if I have employee table. In employee table, what will happen? Like I will have employee ID, and then it can have employee name. It can have, let's
Email
say,
ID.
yeah, I will put address ID. Then I can have email ID as you mentioned. I can have their m- mobile. So let's say one name is, let's say, John. Address ID I'll put right now one. Then email ID abc@gmail.com, something like that. And mobile number can be anything. Similarly, let's say employee ID 2, Mike, and over here address ID 2, or let's say 5, whatever if you want to put, we can do that. XYZ. And again, whatever we want, we cannot put like address ID. I'll tell you why. It has to be some number, incremental number, or it can be alphanumeric number, but there has to be some relation. There is a logic. So this is employee table. Now let's say, because I'm using address ID over here, right? Why? Because I have another table and it will have address ID. So address ID, like in employee table, your employee ID can be your incremental number, like as soon as you insert another record, it will auto increment. Similarly, in address table, you will have address ID that will auto increment. Then address ID, then let's say I have address line number 1, address line number 2, then we can have maybe a zip code, then we have city, state, and country. So these columns are there into the address table. So address ID 1, line, let's say address line 2, maybe near temple, whatever. I have some zip code, then I have this, and India. So this is my address table, right? So the other day, the logic which we were talking about, joins and VLOOKUP, joins and union. We were talking about these two concepts in the previous session. Now tell me, let's say this is my employee table, this is my address table. Get address of this guy, Mike. What will I do? Whether it is, let's say in Excel only, if you need address of Mike, what will you do?
I will join them and I
With
will
this,
use. Sorry,
on what basis you will join?
employee ID.
But it doesn't have employee ID.
Oh yes, address ID. Sorry.
Address ID, right? So address ID is the link between this table and this table right now. It has all the addresses. If you look only at this table, you will not know like which address belongs to which employee, right? Now, if you look, they will realize that employee master or employee table has address ID that can give us the address of related person. And for that, you
Okay.
need to look into the address table. So right over
Looking
here, like even you apply will yeah, you can do VLOOKUP, you can do join in databases, right?
right. Okay.
So basis address ID, if it is address ID is 1 for John, look into this table, you will find address ID 1
Address
is
for
this, and
John.
this is,
Yeah.
yeah, this is the address for John. Same goes with Mike, address ID 5. So that is this, and it will be the address for John, right? So this is how we link the tables in databases. Now again, this is also incremental ID, and this is also auto increment ID. As soon as you will insert data, it will automatically generally see what happens in let's say whenever we onboard an employee or whenever we kind of do similar kind of work, it is generally done through an application. So what happens as soon as, let's say, we filled a form for an employee and we submit that, what will happen, this table and this table both will get filled together. So like address table will get inserted, this ID will be used as a reference key over here, and then we can get the employee details from this ID. Similarly, we can add other IDs also from other tables. So over here, this ID, because it is auto increment for this particular table, this is the primary key, and this table, it is not auto increment, right? This this column or this field is based and related to this particular table. So I mean, for this table, address ID is the primary key, address ID is working as a foreign key for this particular table. Because one table can have only one primary key, and for employee table, your employee ID is the primary key, but address ID is the foreign key. And over here, address ID is the primary key. You don't have any foreign key over here.
Got it. So primary key is basically something which is driving the table. So the left one, the employee table, primary key is employee ID, because only on the basis of employee ID I will have address ID
Right.
and not vice versa. And
Mhm.
in the second address table, address ID is the only primary key. There is no foreign key because there is nothing which sounds linked.
Right.
Right.
So primary
So
key, another property of primary key is like it will be unique in the table. So over here, I cannot have another employee ID with 2. I cannot have another employee ID with 1.
got it, got it. So it acts
Right.
more or less like a VLOOKUP, wherein we need to have unique values to have the correct answer.
Correct.
Correct.
Right.
Right.
So situations like this, what will happen? Your like the tables, for example, I have taken. Let me take another table here, small table. I have got address ID. Let me take table. Let me take department table. Over here, I will have, let's say, department ID. Then I can have department name. Then I can have, let's say, HOD, head of department, and maybe I can have start date or anything, something like that. So department ID 1, and over here department name, let's say human resource. Then let's say maybe I can put Mike's name, and then I can put some date over here. Then maybe department ID 2, or over here I can put, let's say, payroll, maybe John, or information, for example. Okay, so this is the department ID, the department table. Now over here in the employee table, I will have to put a relation with this, and for that I can have department ID, and I know like John belongs to 2 and Mike belongs to 1. So from this ID, I would know like this guy John belongs to which department. Mike, I will get to know that he belongs to which department by department ID. So over here, department ID is another foreign key for this particular table, but for department table, department ID is the primary key.
Primary key. Yes, got
Yeah.
it. Yeah.
I mean, if you drive this, what will happen? This is your master table, you can say, or a kind of fact. I will not say fact table over here because it doesn't have numerical values, but it's a kind of master table, and this is linked with all other tables, right? With the help of these foreign keys.
So it
So
consists of
if you need to,
everything. Yeah.
yeah. So if you need to drive a relation, what will happen? Let's say this is your employee table. In ER diagram, I'm talking about. So let's say this is your employee table, and this is the department table. And this I will treat as address table. So as per this current relation, what is happening? This table is linked with this one, and same goes with this. Like this table is linked with this also. Let us suppose like there are few more tables similar to this. So what will happen? You will have some relations. Your employee table is linked with many tables here. I'm just taking an example.
Yeah, there could be a lot of
Right?
other things
So it
also. Yeah.
correct. So such thing is called a star schema because there is one central table and all other dimension tables are linked with that central table. In case of like numerical fields and all the database what we have right now, over there fact table is linked with all other tables. So this kind of architecture is called star schema in database, right? There could be another scenario wherein I cannot select. So
Star schema, right?
star schema. This is called STAR schema. And there could be another scenario wherein it's possible that now I'm just using it as a table, will not follow this particular data which I have. So there could be a thing like this table is linked with this table, and then this table is linked with this one, and this table is again linked, maybe let's say this table, or this table is related to this one, right? But there could be another table. Okay, so if you see here, uh, there is no central table kind of concept
It's
the way
a
we were talking
yeah,
about in the first one. Hmm.
it's a distorted
Over here,
connection, and each table can relate to anyone.
yes, right. Or it could be possible like you can have multiple stars in it, right? For example, this table is linked with this one, right? So it's a kind of mini start. Over here, like 4 tables were connected. Over here, 3 tables are connected. So it's a kind of your star schema kind of thing over here. But if you look at the overall structure, there are a number of stars. One is this one, another is this one. It's possible that this table is further linked with any other table, but there is no direct link with department table. So this schema is generally called either, like, people call it like star of stars, right? But it is not that known. It is known as Snowflake schema. This is the actual name through which people know it. Snowflake schema. It can have multiple stars, but the kind of pattern what you get in the star schema, you will not find that here. Right? Both are different architectures of database, and are followed in SQL, Oracle, anywhere in any of the databases. But again, this linking will happen basis because that is the key of the relationship. Any table. Is that
Okay.
clear?
Yes, yes, sir. I'm clear with both the tables.